Hello, this is my code review for the CS499 capstone project. For category 1, software design and engineering, I chose my CS210 programming languages project. Just do a quick scroll through so we can see everything right at the beginning here. Um, so this program is currently a C++ console-based inventory management tool designed to read and process text-based inventory data from a small grocer. It defines a class item that encapsulates a few functions. So if we scroll back to the top here, it encapsulates item search, print list, print histogram, and create backup file. So item search counts and displays the number of times a specific item appears in the file. Print list reads the inventory file and prints a frequency list of all items. Print histogram displays a visual histogram using asterisks to represent item counts. And create backup file writes the item names and counts to a backup file. There is a menu function which provides a looped user interface, letting users choose between search, list, histogram, and exit. And the main function at the bottom opens the input file and starts the program loop. So just a quick demonstration of that. So starting the program opens up the console, and then we can do print list of items to see what is currently in the program. Then we can do 1 for item search, and then we'll look up yams. So we can see there are 5 yams. And then 3 for print histogram, and it'll show with asterisks how many of each item are on the list. And then 4 will let you quit the program. And that is it there. So this program uses maps for tracking, item frequencies, and C++ file streams for input and output. It assumes the input file is formatted with 1 item per word. So the strengths of this program are the modular design, the separation of logic into a class, the item class, with specific responsibilities improves the organization of the program. The use of the map is good for tracking frequencies and supports automatic sorting by key, and the basic functionality works as intended. There are some areas for improvement in this program. There's no input sanitization or checks to avoid invalid strings or buffer overflows, so that is a security issue. This program lacks file and input validation in multiple areas. The hard-coded file name down here that is an issue because it restricts reuse with other data sets, and the program could benefit from more comments throughout. So word counting logic is duplicated across 3 of the functions. That is print list, the histogram, and the backup function. So print list, histogram, and backup. And the menu requires a restart to load a new file or perform additional tasks. So enhancements I have planned for this are a dynamic file selection, which would prompt the users to enter file names at runtime, and it would add file existence validation. I'm planning on expanding error handling. So I would handle invalid menu inputs, unreadable files, and defective content. And I am also thinking about changing one of these while loops here. It was actually towards the top. This while loop here with a safer while loop. I would improve the menu design by adding an option to reload or switch input files. I would allow multiple searches in a row without having to restart the application, and I would enable saving backups at any time. For input and data validation, I would add checks to reject wrong item names with like symbols or empty strings, and I would prevent incorrect user input from crashing the program. For refactoring, I would move repeated word counting logic to a private helper function, and I would add comments throughout to improve the clarity of the program and improve naming consistency throughout. So the skills demonstrated here include software design and modular programming through menu restructuring and the helper functions. Error handling and input validation is also demonstrated here by using safe input techniques and runtime checks. User-centered design will also be demonstrated by improving the flexibility and interactivity of the menu, and code maintainability and reusability will be demonstrated with improved structure and abstraction. So with this category, the course outcomes covered will be outcome 1, to employ strategies for building collaborative environments. So the improvements made in usability and adaptability make the code easier to collaborate on or reuse in team settings. Outcome 2 will also be covered, and that is designing, developing, and delivering professional quality communications. The improved menu clarity and program feedback will support user understanding and communication of system behavior. And then outcome 4 will also be covered, and that is to use well-founded innovation techniques and tools. So refactoring, the modularization, and reusable file parsing logic that applies to important software engineering techniques. For category 2, which is algorithms and data structure, I chose my CS499 data structures and algorithms project. And this project is a C++ program, and it is a console-based course planner that loads course data from a CSV file and organizes it using a hash table. And this lets users load course data from a CSV file into a hash table using the course number as the key. It'll print a sorted list of all courses based on course numbers. It'll search for and display details of a specific course, including its prerequisites, and it'll convert user input to uppercase for consistent searching. It'll interact with a basic menu for navigating options. So just another quick demonstration. Wait for it to load. Okay. So first off, we can print the course list with option 2. No course data is loaded. So option 1 loads the data, and then you can see courses successfully loaded from the file. And now we can print the course list. And these are all the courses in the list. So 3 to print the course. We'll choose a course towards the bottom here. Let's do CS400. And this will show the name of the course and then the prerequisites for the course. And then finally, we can hit 9 to exit the program. So the course structure stores each course's name, number, and a list of prerequisites, while the global unordered map manages the collection of courses for a quick search. The strengths of this program is the use of hash table that provides efficient search of courses by course number. Course data is parsed line by line from a CSV with multiple prerequisites. The menu navigation is a functional interface to guide interaction. Um, and the code structure is modular in the function definitions, and that is load courses and print course list. So load courses, print course list. So some areas for improvement. The global unordered map should be encapsulated in a class to improve modularity and reduce risk of unintended side effects. There is no validation of prerequisite integrity, so like ensuring prerequisites exist as defined courses. There's no exception handling for defective CSV lines, missing fields, or input errors. And for large data sets, searching and validating courses could be optimized with better algorithm design. The code is missing some object-oriented principles. All functions operate independently without encapsulating. And the program could benefit from more comments throughout. So the enhancements I plan to make to this is to encapsulate the logic in a class. I would replace the global unordered map with a private member of a new course planner class, and all related functions, the load, the search, and the print, would be grouped as class methods. I would add prerequisite validation algorithms, or a single prerequisite validation algorithm. During or after loading, it would verify that each course's listed prerequisites exist in the data, and I would improve error handling by adding checks for defective lines, empty fields, and invalid menu selections. The skills demonstrated here are data structure selection and analysis by refining the use of hash maps, algorithm development by creating validation logic, object-oriented programming by moving to a class-based structure, error handling by introducing input checks and edge case handling, and code readability and maintainability with improved organization and documentation. So for course outcomes, outcome one, employ strategies for building collaborative environments would be covered by refactoring for modularity, and this would enable team development and reuse. Outcome three is also covered, which is design and evaluate computing solutions using algorithmic principles. Enhancing algorithm design supports this outcome. And then outcome four, use well-founded and innovative techniques is covered by applying encapsulation, validation, and efficiency improvements through the program. Okay, and finally for category 3 databases, I chose my CS320 software testing, automation, and quality assurance class, the project for that class. And so we have the contact.java file, we have the contact service file, and then we have the two tests. We have the test for the contact service, and we have the test for the contact file. Okay, so this is a Java-based program, and it implements a contact management system with support for basic create, read, update, and delete operations. The project includes, I just went over, it includes the contact file, and this is a model class with validation logic to represent individual contacts, including fields like ID, first name, last name, phone, and address. And the contact service file is a service class that uses a hash map to manage contact entries, and it includes methods to add new contacts with unique IDs, delete contacts by ID, update specific fields of a contact, and retrieve contacts by ID. And then this project also includes unit tests, the contact service test and the contact test. They validate functionality of both the model and the service logic. All data is currently stored in memory and no external database is used. And so once the program is stopped, all the contact data is lost, which makes this a good candidate for the database part of this project. So the strengths of this code is that the program is separated into model and service layers, so the contact and the contact service, and then the test classes are structured and cover many cases. Input validation is good and is built into the contact constructor, which prevents invalid entries at creation. Both model and service functionality are tested using JUnit with appropriate coverage of edge cases. The data members are private with public getters. Business logic is separated from the data model. There are some areas for improvement. The current implementation is used in memory storage, like I said earlier. The contact data is not saved between executions, and this limits the scalability and usability of this application. The hash map works for small scale temporary data, but it doesn't have support for persistence, queries, indexing, or concurrent access. There's no use of SQL or JDBC or persistent storage. The current system has no SQL layer. However, any future database implementation should be careful to use parameterized queries to prevent SQL injection. The update contact method repeatedly recreates contact objects for each field update, which can be inefficient and error prone. This could be restructured for clarity. Exception handling is missing for operations that may fail in real-world scenarios like database access, defective user input, or connection failures. So enhancements I have planned for this project, so I will integrate a MySQL database for persistence, and this will allow the contact data to persist across sessions and improve scalability and reliability. I will redesign the data layer using JDBC, which is Java Database Connectivity. It will replace the in-memory hash map with the SQL-based CRUD operations. I'll use prepared statements for all queries so I can mitigate SQL injection risks. And I will add connection pooling or reuse where appropriate. And I will improve contact service by refactoring methods like add contact, delete contact, update contact, and get contact to perform database operations instead of interacting with a hash map. And I will introduce integration tests to verify database interaction and ensure data consistency. So the skills demonstrated with these enhancements are database design and querying, designing relational tables and writing CRUD queries demonstrates data modeling and SQL fluency, secure coding with prepared statements, using JDBC with prepared statements prevents SQL injection and supports safe query execution, software modularity, separating the data layer from the service layer supports clean architecture principles, testing for data integrity and failures, writing integration tests for database interactions shows test-driven development skills. And now for the course outcomes. Outcome 3, design and evaluate computing solutions using algorithmic principles will be covered. Refactoring the update logic, integrating database interactions, and using structured query logic all support this outcome. Outcome 4 will also be covered, and that is use well-founded and innovative techniques in software design. By applying the JDBC, secure queries, and persistent storage techniques, they all align with this outcome. And finally, outcome 5 will also be covered, and that is develop a software solution using appropriate database technologies. The transition from HashMap to a MySQL-based system directly covers this outcome. And that is it for my code review. Thank you.